We're continuing with Chapter 4 of the Statistics textbook. In this video, we're going to go through Section 4.6, which is on computing the standard deviation. So in the previous video, we went through Section 4.5, where we were introduced to the standard deviation. That was 2 videos ago, and then in the previous video, we worked the example problems from that section. But in that section, we were introduced to the standard deviation, and we really went in depth on the concept of what the standard deviation means, which is very important, just as important as knowing how to compute it. But we did touch on how the standard deviation is computed. We didn't go into any formulas, but what we talked about was that the standard deviation is the RMS deviation from the average. So this is another conceptual way of looking at what the standard deviation is, but it also kind of hints on what the formula is going to be too. And so from a calculation standpoint, what you're doing to calculate the standard deviation is you have a list of numbers. And again, I'm going to keep mentioning this, but when you see a histogram, behind any histogram is just a list of numbers. You see a chart and you see a horizontal and vertical axis, and you tend to think, well, that's 2 different variables that are being related. Yes, that's true. In general, that's true, but not for a histogram. We've talked about these different studies, the Haynes study, and where they collect data on a population of people. They collect a bunch of different data points, but there's histograms for each data point. So if you have 3,000 people that were surveyed, they all had a certain height. That's one category of numbers. That's one list of numbers, 3,000 numbers. You can make a histogram on just that list of numbers. You can make another histogram on their weights, right? The vertical axis in a histogram is just representing the count. It doesn't equal the count necessarily, but it represents kind of the number of data points from that list of numbers that were in an interval. And that's why you could talk about the histogram having an average or a standard deviation or a median, because it's just a list of numbers, right? You take any list of numbers, you put it in ascending order, you can find the median, you can find the range, you can find the average, you can find the standard deviation, okay? And so the standard deviation, to calculate it, we talked about what the RMS is, the root mean square, a few videos ago. If you want to find the standard deviation of a list of numbers, you don't have to put it in ascending order for the standard deviation, but what you do is you find the average of those numbers, then you go to each data point and you find the amount that data point is different from the average. You can put it as a negative or positive deviation. You could put a negative sign if you want, it doesn't matter. Then of those deviations from the average, all of those, you find the RMS of those deviations. So root mean square. We talked about how to calculate root mean square. Go take the name and go in reverse. Square all the numbers, then find the mean of those squares. So you add up all of those squares and divide by the number of data points. Then take the square root, root mean square. That's the standard deviation. It's the RMS of the deviations from the average. So you see, this kind of gives you both a conceptual idea of what standard deviation is as well as the formula for it. So to find the standard deviation of a list, take the entries one at a time. Each deviates from the average by some amount, perhaps 0. So they're saying perhaps 0 because, yes, when you sum the squares, 0 squared is 0, so that's not going to contribute to the sum of squares. But that still is relevant because you're going to include that as one of the points. So when you take the mean of the sum of the squares, that 0 is a point, so that's included in the count, right? So the deviation from the average is the entry minus the average. And it might be negative, it might be positive, it doesn't matter because you're squaring that value, that deviation anyway. And then, find the RMS of those deviations from the average. So find the standard deviation of this list of numbers. So get the average of that list, there you go. Find the deviation of each point from the average, then find the RMS of this. Square each of these. To find the average of those squares, you sum the squares, divide by 4, take the root. That's the standard deviation. The standard deviation comes out in the same units as the data. For example, suppose heights are measured in inches. The intermediate squaring step in the procedure changes the units to inches squared, but the square root returns the answer to the original units. Do not confuse the standard deviation of a list with its RMS size. The standard deviation is the RMS, not the original numbers on the list, but they're deviations from average. All right, so first of all, it's saying that, all right, if we've got a list of numbers, so a list of, what is this? Let's say we have a list of heights. So 62 inches, 60 inches, 55 inches, etc. If we take the average, so you sum all of the values, the units of the sum is inches. Divide by just a number like 10 or whatever the number of data points are. The average, the units is inches. And that makes sense. What's the average? It's going to have the same units as each of the data points. Standard deviation, you expect to be the same thing, the same units as the data points. And that's what it is, because you first find the deviation of each value from the average. So 62 inches minus the average, let's say it's 55 inches, you get something else in inches. So those deviations are in inches. You square each of those and sum them. The sum of the squares is like inches squared. You take the average, it's still inches squared, but you take the square root, that inches squared goes back to inches. The median is going to be in inches. The range is going to be in inches. And then it just says, don't confuse the standard deviation of a list with its RMS size. I could find the RMS if I had a list of heights and I wanted to know how large are these heights in magnitude, just the magnitude. I could get the RMS of the list. That's the RMS size. That's not what the standard deviation is. The standard deviation is the RMS of the deviations of that list from the average. It's not the RMS of the list itself. So again, don't confuse the RMS of the list itself with the standard deviation. Okay, now before we work the example problems, let's come here. Let's go through this. There's this last section here before the chapter review exercises. All this is talking about here is if you're using a statistical calculator, you know, your personal calculator, your graphing calculator, or just even like a coding software like Excel, for example, there's two ways of calculating the standard deviation. So you might be confused. We haven't gotten to the second way yet. That'll be in a later chapter. But it talks about there's the SD plus and then just the SD. What we just talked about is the SD, not the SD plus. One is a standard deviation based on a sample, and one is based on a population. Again, we'll talk about what that means in a later chapter. But it says the distinction between standard deviation or these two will be explained more carefully in section 6 of chapter 26. To find out what your machine is doing, put in the list minus 1, 1. If the machine gives you 1, it's working out the standard deviation. If it gives you 1.41, it's working out the standard deviation plus. So let's come to Excel. Equals standard. I mean, there's all kinds of different standard deviation options here, and we'll learn about all of this later. But they're referring to, if we take this, see, that's the SD, no plus, is what they're referring to, standard deviation of a population. But if we do the sample, that's what they're talking about. And later in the course, we're going to go into a lot more detail on what the difference is between those two. And then also you saw in Excel there was more options than just these two. So we'll talk about all of that. But if you're getting this is the standard deviation of a sample, and you want the standard deviation, you have to multiply by a conversion factor. This depends on the number of entries on the list. With 10 entries, the conversion factor is square root of 9 over 10. With 20 entries, it's square root of 19 over 20. So in general, if you want to convert between the standard deviation of the sample or vice versa, because you could bring this to the other side, right? You divide this by 1 and to bring it over here. The conversion factor is the number of entries minus 1 divided by the number of entries. Take the square root of that. And you'll see where this we'll talk about where this comes from. It's really simple. But yeah, just keep this in mind for now.